it. Okay, so moving on the video. Problem 6. So we did graphing, but what I did not show you is how to graph in standard form. The only thing I can take away from standard form right now is the y-intercept of 0, -8. So I'm going to go ahead and put that on here, and you guys will see this point ends up in our final graph. And actually, I think I'm going to use an X instead. My eraser does not want to work here, so let's see if we can get this to work. Okay, well, it's not going to work. Anyway, so going back, I'll make it an X. What I need to do is get this into vertex form. So I'm going to be grouping my X's. And as I group my X's, I will need to make sure that it is... Okay, so I had to do a little racing here. I had to pause for a moment. So I'm going to be grouping these X's, and to make it ready to get to vertex form and completing the square, I will be factoring a 2 out. Okay, so I factored a 2 out of the 2x squared and the 4x. There's my blank. And here's the add and subtract blank. I will be taking -2, cutting it in half, or -1, squaring it, which is 1. But again, I'm going to have to remember that this is not really worth 1, that this 2 is making that 1 really worth 2. And so even though I wrote 1, I added 2, which means on the outside I'll subtract 2. So again, usually where I start is on the outside of the parentheses. I'm just going to show you that if I add the opposite and add the opposite, that this becomes -10. Okay, in my parentheses with the squared will be this number, so x minus 1. And then I hope I don't forget the 2, because all of these things are going to help me get it ready to graph. Okay, so what's going on? This 2 will make it stretch. Whoops. This 1, I'll take the opposite. So the -1 makes me take a 1, which makes it go right 1, and the -10 will make it go down 10. So we talked about that you have your parent function points. I'm going to put them over here. And for x, we always choose these numbers. And the parent function is x squared. So squaring those will give me my y. So 4, 1, 0, 1, and 4. Sometimes we make another y column, and that happens when we have a stretch, a compress, or a flip, which we have over here. So I'm going to take all of these y's and just double them, because my y is 2. If it were a -2 and there had been a flip, then I'd multiply everything by -2. But here's multiplying everything by 2. And I don't need these old y's. I'm going to graph the new x and the new y. So -2, 4. What was here is actually now stretched to up here. And -1, 1, which was there, maybe you can see that little dot, is now stretched up to -1, 2. 0, 0 is like an anchor. 1, 1, which was there, is now up to 1, 2, and 2, 4, which was there, is now up to 2, 8. So this is the beginning of my transformation. I've applied the stretch. So now what I'm going to do is take these points and move them all right 1 and down 10. So you can't see me counting, but they're all going right 1, down 10. So right 1, down 10. I'm going to mark a different color. Right 1, down 10. Right 1, down 10. Right 1, down 10. And they're all just going right 1, down 10. And once I do that, I've got my U. Remember, there is always an axis of symmetry going right through the vertex. This axis of symmetry, even though I didn't ask, is x is 1. Okay, let's go on to the next one. So I'm going to be skipping 7. I'm going to go to 8. So unfortunately with 8, I cannot show the graphing calculator, but I did go to y equals. I typed this in, I pressed zoom 6, and I got a standard window. And then by using the second trace button, I got this shape. Something like this. And you will be expected to mark all the important points on your graph, otherwise I will not be grading this question. So I will need my x-intercepts, my y-intercept, and my vertex, and the arrow. So I'm actually going to start with the arrows because I don't need the graphing calculator. On the left, x is -infinity. On the right, x is infinity. Since they're going down, that means the y's are going down, and that gives the y's to be negative infinity. The one point I don't need the calculator for is the y-intercept. I can see that this will be 0, 5. And I am going to give you the vertex. You will have to use second trace and the 0 option to find the x-intercepts. So this is negative 1.25 and 8.125. Again, what I used was second trace, and this is a high point. This is a maximum, so I will be putting that. I did have to round, and the directions said round to the hundredths. I didn't round this because the decimal's so short, but I did have to round this. So a few of these that I'll go through is domain. Remember, domain throughout this whole chapter is ARN, or you could do this. Since I have the range on here, I'll put that. Remember, domain is X, range is Y. So I want the lowest Y to the biggest Y. So what I'll do is move up. The lowest Y is negative infinity, and as I move my way up, the highest Y is this 8.125. So I'll put negative infinity to 8.125. Domain and range is the only time we use brackets as far as numbers go. You will need to do positive, negative, interval of increase, and interval of decrease. So just a reminder, okay, so I'm going to be using lots of different colors here, that this is the increase, and then this is the decrease. When you have positive and negative, that, let's see, this part is negative. And then I switch to positive, which will be, try this color, see what happens. This is positive. And then I'm going to switch back to negative right here. Okay, a lot of colors. Look how pretty that is. All right, the only other thing I'm going to put is the end behavior. Remember the end behavior, I'll write one of them, but you'll still have to finish the answer. Here's one. On the test, I do not even provide one. You're going to have to remember this. And then there's another one, but remember, you still need to answer it. Okay, last one, number 9. So the path of a golf ball can be modeled by, they gave me this equation. They actually graphed it for us. You could also put this in your graphing calculator if you'd like. And when you set your window, you would note the x-min. We could do from negative 40, and the x max is to 340. And when they say the x scale, I'm going up by tens. And then when I do the y min, they have negative 10 up to 100, and then the y scale could go up by tens. Again, I can't show the graphing calculator on this, so it's just something to keep in mind. All right, so they mentioned that this is the path of a golf ball, and y is the height. They want us to write this, the height in feet. And the x is the distance traveled in feet. And so that's what A wants me to do. So a few questions to go over. I'm not going to do them all, but approximately what was the height of the golf ball? So again, this is approximately. If I did want exact, I could put this in the graphing calculator, and then I could choose second trace and choose value and put in 90 feet, because horizontally is me looking on the x-axis, and so I could just choose 90. Anyway, if I just look here and I go over to 90 and I go up, that's about here. So I thought it was about 84 feet. Maybe you could say 85, 83, whatever. The actual answer, and I checked on the graphing calculator, is actually 83.8 feet. If you want to know how to get that exact, call me over and I will show you. The next question I'm going to answer is E, what domain? So which x's, which distance traveled makes sense? So I don't need all of this view, and I actually don't have a lot of it on here, but I only need this part from here to here, because once I go below the y-axis, then the height of the ball is negative, and you're not going to have a negative height. So I'm going to say that it's a good place for it to start is at 0. And to end at 300 feet, and they want this in interval notation. This is domain, so I will use brackets. Average rate of change, we did very little with this, so I just, but you guys do know this. Average rate of change is slope. Slope is when you subtract your y's over your x's. And what I'm doing is giving you here are the x coordinates. So if x is 25, I'll need to know its y. And if x is 90, I'll need to know its y. Well, I already know that from problem B, I said it was about 84. And if I go up to my graph, when x is 25, that's about here. So I'll say the height is 30. So I'm going to subtract my y's. I'm going to choose to do 84 minus 30, and that gives me 54. That means I'll have to subtract my x's the same way, 90, take away 25, so that's 65. But average rate of change is when the denominator is 1, so I'm going to divide this on my calculator, and just rounding it to the nearest hundredths, I get 0.83. But what does this mean in context? Well, this is the height of the ball in feet, and this is the distance it's traveled in feet. So to explain this, I'll just say for every 1 foot in distance, the ball increases in height. I'm going to go into the other one by 0.83 feet. Okay? G is increasing and decreasing. The last one, and then I'm done, is to discuss 10. I give you the points, you're going to graph it. But again, here comes that average rate of change. And I want you to find the average rate of change from the y-intercept, which I don't even need the graph. Here's the y-intercept, to the positive x-intercept. So there's 2 x-intercepts, and I want to use the positive one. So these are the points you will be using when you subtract your y's and your x's. You'll be using 0, -8, 2, 0, and again, you are not done until the denominator is 1. Again, make sure you label these points on your graph for when you answer these questions. All right, and that's it.